In this lesson, we will be looking at some different methods for solving some quadratics again, or solving equations with quadratic kinds of techniques. In this first problem, you'll notice that there's 4 terms to it, and you have no like terms that you can combine. And so when there are 4 terms, what you want to do is you want to be able to factor this by grouping. And when you factor it by grouping, I'm going to group these 2 together, and then I am going to group these 2 together. Okay? So what you want to do is you want to take out of what I underlined in blue, you want to pull out what you can, what they have in common, and they all have at least an x squared to them. And then x squared times x will give you your x cubed, and x squared times negative 3 will give you your negative 3x squared. And then you want to look at what I underlined in red, and what you can pull out of there is a positive 7. So if I pull a positive 7 out of there, positive 7 times x gives you positive 7, and then 7 times negative 3 will give you the negative 21. Okay, and so that you've got that equal to 0. Then I want you to notice that both terms have, both what's in blue and in red, have an x minus 3 in them. So you can think about factoring the x minus 3 out. So if I factor the x minus 3 out, when I pull that out of here, what I have left is this x squared term. And when I pull the x minus 3 out of here, what I have left is the x plus 7 term. Okay? Sorry, and I messed this up. Plus 7. Nope, I did that right. 7. And I just forgot my square there. That's where I'm confused. Okay? So I pull out the x plus 3, or x minus 3, and I have x squared plus 7 left. Okay? Now I am going to think about factoring each one of these. Of course, I can set this x minus 3 equal to 0, and then x equals 3. That's no problem. And here I have x squared plus 7 equals 0. And I can't, that's not a perfect square. I can't factor it, so I am going to move that 7 to the other side to make this. And then, of course, to solve something that's squared, you're going to need to take the square root of both sides. And when you take the square root, don't forget to do plus and minus. So I have plus or minus the square root of negative 7. And, of course, you can't have the negative underneath the radicals, so then you need to pull that I out of there. So positive or negative I root of 7 is what that would look like. Okay? Now I will do this one too. It is very similar to number 1. So some of you may be able to buzz through this quickly. But again, it's got 4 terms to it, so I will factor by grouping. When I underline that, again, they have an x squared in them that they have in common. And when you pull that x squared out, then you'll have x minus 3 left in the parentheses. And then when I take this and I pull it out, be careful here because what you want is the same thing in both parentheses. So because this 4 right here is negative, you're actually going to want to pull out a negative 4. And when you pull out a negative 4, then you'll have x, and then it's a negative 4 times a negative 3. That makes a positive 12 when you distribute that through. And now notice that they both have an x minus 3 that I pulled out, versus pulling out a positive 4, and then what you would have in parentheses would be opposite, and that wouldn't work so well. Okay? So now, of course, they both have an x minus 3 in them, so I can factor that x minus 3 out. When I pull that out of here, I will have x squared, and when I pull that out of here, I will have negative 4. Okay? And then, of course, right here, we know that x equals 3. And right here, this does factor as a perfect square. So x times x makes that, and then, oops, sorry, 2 and 2, of course, 1 positive, 1 negative, and x will be negative 2 here, x will be positive 2 here. Okay? Or, of course, you could have moved the 4 to the other side and taken the square root as well, either way. All right, now we're going to deal with factoring some quadratics that have fractions as their exponents, which is really kind of weird, and I know you haven't done that before. You're going to factor this the exact same way. You just have to kind of deal with solving it a little bit differently. Okay? So, here's the deal. When you factor this, obviously you're going to sit and make two parentheses like always, and of course the two fronts have to multiply together to make the back. Okay, now I'm going to give you this little hint. Your middle term gives you a big clue about what exponent your two fronts should have, okay? Because I need to multiply two things together, an x to the something power up here and an x to the something power up here. And when I multiply those two things, I have to be able to get x to the 2/3 power. So I want you to think about this. If I'm multiplying, this is just kind of a side note. If I'm multiplying x squared times x to the third, I would add those two exponents and get x to the 5th. Okay? Now I'm needing to find two things that when I take x to the something times x to the something, I need to add this exponent and this exponent and get x to the 2/3. Okay? Here's your big hint. Your middle term right here gives you a big hint about what to add. If you take x to the 1/3 times x to the 1/3, you have x to the 1/3 plus 1/3, which is x to the 2/3. Okay? So that middle number is going to give you a big hint about how to have your exponents. So I will have x to the 1/3 up here and x to the 1/3 up here. All right? And then, of course, your two backs have to multiply to make 5. You only have one choice, 1 and 5. When it's a positive at the end, then it either needs to be plus, plus, or minus, minus. Because you have this minus right here, it'll be minus, minus. Okay? And then, of course, you're going to set each of these equal to 0. So I have x to the 1/3 minus 1 equals 0. So x to the 1/3 power equals 1. And you undo that 1/3 power by cubing it. So if I cube that, then of course that outdoes each other. And 1 to the 3rd power, 1 times 1 times 1, is still 1. Okay. Over here, of course, I will have x to the 1/3 minus 5 equals 0. So x to the 1/3 power equals 5. And again, you undo something that's to the 1/3 power by cubing it. That undoes itself. And then 5 times 5 times 5, it's not 15, but 5 cubed is 5 times 5 times 5, which is 125. Okay? Now, when you have these fractional exponents like this, you always need to check your answers. So I would plug these in, and I would, even on your calculator if you want, and go 1 to the 2/3 power minus 1, or 6 times 1 to the 1/3 plus 5. So plug these in, basically, is what I'm trying to tell you. And you should get 0 in there. Okay, so I'm going to just check this. Okay, I'm plugging 1 into my equation. I'm going to go to my main screen. And again, I'm just plugging 1 back in. So I'm going to go 1 to the 2/3 power. Notice how I'm putting that in parentheses. Minus 6 times 1. And I know I don't need to really do this because 1 to the anything is 1. But 6 times 1 to the 1/3 power. And then plus 5. Okay? And you should get 0, which I do. If you don't get 0, it doesn't check. And then you can do the same thing with 125. And I will tell you that 125, when you put that in, it does check. But they won't always check. So you have to plug them in and check them. Otherwise, you might have what are called extraneous roots. And we'll talk about that in a couple problems here. All right, this is very similar, you guys. So if you want to, again, fast forward through this one, I think you'll probably be okay. But you're going to factor this. And again, I have to figure out two things that when I multiply them together, it gives me x to the 1 power. Here's your big hint right here, your middle term. So you're going to take x to the 1/2 times x to the 1/2. And remember, when you're multiplying those, you really add the exponent. So 1/2 plus 1/2, of course, makes x to the 1, which is what you have in front, which is fabulous. Then in the back of each of those parentheses, you need to multiply two numbers together that make -10. So your choices are 1 and 10 or 2 and 5. I'm, of course, going to try 2 and 5 here. When it's a negative at the end, you need a positive and a negative. So I'm going to make this one negative and this one positive. And if you check your outsides, these two right here, of course, you have -5x to the 1/2. And if you check your insides, you have 2x to the 1/2. And 5 plus 2, or negative 5 plus 2 makes negative 3. So you should be good to go there. Okay? All right, set each of those equal to 0. So of course, x to the 1/2 here equals negative 2. And then you are going to undo that 1/2 power by squaring it. And then you get x, that undoes itself. 2 squared, of course, is 4. Okay, so there's one answer. And over here, we will have x to the 1/2 equals 5. And square that. That undoes itself. And so you'll have x is 5 squared, which of course is 25. And again, I want you to plug these in and check them. Okay, and I'm going to check 25 this time. So all I'm going to do is go to my calculator. I'm going to plug 25 in. Okay, so my question is, does 25 minus 3 times 25 to the 1/2 power minus 10 equals 0? And it does. Okay, so I'm good, but check them, and I will tell you that these both check in this case. All right, then this one is a little bit different because you've got a radical in there, and it's not set equal to 0, so you need to kind of think about that a little bit. First of all, I'm going to move that 7 over, so I have minus 6 times the square root of x minus 7 equals 0. Okay. Then on this one, if that radical is kind of freaking you out, you need to remember your rules about how to change things from radicals to fractional exponents. And so remember that there's this imaginary 1 right here, and there's this imaginary 2 right there. When numbers aren't written, that's how it goes. And then, of course, those become a fractional exponent. So this is really, the square root of x is really x to the 1/2 power. And now, from here on out, it's very similar to the last one. So if you want to kind of fast forward this, you probably could. Otherwise, I will factor this for you. Okay. All right, again, your middle number is your hint. So I will go x to the 1/2 and x to the 1/2. Of course, it has to be 7 at the end. My only choice is 1 and 7. It's negative, so I need a negative and a positive, and that's how that one should factor. And then you have x to the 1/2 equals negative 1. Square that. And negative 1 squared, of course, is positive 1. Okay, so there's one answer. And then on the other one, I'll have x to the 1/2 equals 7. Square that. That one does itself, and I will have x equals 49. There's another answer. Okay, so I want you to plug these in and check them. So I'm going to check one here really quick, and I'm going to see. Does 1 minus 6 times the square root of 1 minus 7 equals 0? And it doesn't. It equals negative 12. Okay, so you have to check these. And I'm not going to check every single one of them on my calculator, but I will tell you that the 1 on this problem does not check. It is not a solution. But 49, when you check it, does check. So 49 works, 1 doesn't. So don't have that circled as an answer because it doesn't check. All right, very similarly here. Again, that square root of x in the middle is the same thing as having 6x to the 1/2 power. Okay, I will factor this for you. Again, your middle number is your big hint here. So this becomes x to the 1/2 and x to the 1/2. And then I have to get 9 in the back. It could be 1 and 9 or 3 and 3. I'm going to use 3 and 3 here. Has to be one plus or both pluses, either both pluses or both minuses when it's like that. Okay, so notice you'll have double roots here if this works, and it doesn't you're going to have the same answer both places. So I have x to the 1/2 equals negative 3. And then I will square that to solve. So I will square both sides. Negative 3 squared is 9. Okay? So again, I'm going to plug that back in and I'm going to check it. And by the way, if I were to do this over here, I'd have the same answer. So I don't need to repeat that. But I'm going to plug 9 in and I'm going to check it. So my question is, does 9 plus 6 times the square root of 9, which I know you know is 3, so I don't really know why I'm typing that in, plus 9 equals 0? And it doesn't. It equals 36. And so, guess what? This didn't work. And you don't have any solutions in this case, so here we go. No solution. Okay? All right, one last one, and we are done here. Okay? So here we go. You're, again, going to factor this. I need to figure out x to the what times x to the what when I add the exponents makes x to the third. And again, here is your big hint right here. So this will be x to the 3/2 and x to the 3/2 in the front. To get 8 in the back, I could go 1 and 8 and 2 and 4, but I have a negative 9 in the middle, so I am going to go 1 and 8. And it's a plus at the end, so it either needs to be plus plus or minus minus. This, of course, will be minus minus because of this right here. So I have x to the 3/2 equals 1, and x to the 3/2 equals 8. Okay? Now, to undo this, you're going to use the reciprocal, so you're going to go to the 2/3 power. So boom, boom, like that. And of course, 1 to the anything is simply 1. Okay, so that's not a problem. 1 to the anything is 1. And again, you should check that. And then over here, when I take this to the 2/3 power, and of course you can use your calculators to help you if you don't want to do this by hand, but you certainly can do that. You are taking 8 to the 2/3 power. I want you to remember how that kind of works then. The bottom number becomes your index over here, and the top number is your exponent. So this is really the cube root of 8 squared. So if you take the cube root of 8, that's means what times what makes 8. So that would be 2, and then square it, and of course you get 4. So your other answer is x equals 4. And you should plug these in and check them. I will tell you they both work. So there you go.